Okay, this is Circles Lesson 3. We're going to be working with finding arc length and area of sectors. Let's, before we get started, remind ourselves of a couple things. Some formulas. To find arc length, we use our central angle over 360 times the circumference of the circle. So that's 2 times the radius times pi. Your answer is going to be in fraction form. I prefer it to be in reduced fraction form, but improper fractions and not mixed numbers. We also have arc measure, which, remember the difference between these, like if I was finding arc AC, it would look like that. Arc measure of AC has an M there. The M stands for measure, which would mean that I'm finding arc measure, which is really simple. It's just the same as the central angle, and it's measured in degrees, of course. So that one's really easy. If you see an M, you're like, oh, this is awesome. This is an easy problem. All right, and the last formula we're going to need is to be able to find the area of a sector. And that's very similar to the arc length formula. We start with the central angle over 360 to get the fraction of the circle we're working with, but then we want to find area, so we use the area formula, which is r squared pi. You're going to again get a fraction. You need to put it in reduced form, and I would prefer you not use mixed numbers and instead just use improper fractions. Okay, so I'm going to be utilizing these formulas, assuming that you know them, in our next problems. Let's get started. So for arc length, again, there's no M here, so I know this is an arc length question. I'm going to use the central angle of arc ADC, which is 225. So central angle is 225 over 360 times by the circumference, which is 2 times the radius times pi. The radius I see here is 7. If I put that over 1, this works a little bit nicer since I'm working with fractions. Let's start by reducing the first fraction. When reducing fractions, I pick the smallest number, in this case 225, and I think about big numbers that can divide easily into 225. With some guess and check, I know that 225 is divisible by 5, by 25, oh, and by 45. 45 is a pretty big number. I check 360. 360 is also evenly divisible by 45. So both the top and the bottom numbers, I'm going to divide by 45 just to make these numbers more friendly so I can work with easier fractions. 225 divided by 45 is 5, and 360 divided by 45 is 8. And then I have 2 times 7, which gives me 14 pi for the other fraction. Now I can go ahead and multiply straight across. 5 times 14 gives me 70 pi. And 8 times 1 on the bottom gives me 8. Before I put this as my final answer, I want to check and see if this is divisible by anything. Well, both of these numbers are even, so they're at least divisible by 2. Let's start with that. $70 divided by 2 would give me 35 pi. And 8 divided by 2 would give me 4. Since 35 and 4 don't have the same type of factors, I think that's my final answer. I have 35 pi over 4. We're measuring a length, so we'll just say feet for this problem. All right, the next one, we are finding the measure of arc ADC. So ADC, the measure is just the central angle, so that would just be 225 degrees. Remember, when you see that M, it's the easy one. It's just the central angle in degrees. Finally, we're finding the area of the sector. So we're going to need to do a formula very similar to the last one. We're going to do central angle of 225 over 360. And then now we're going to times it by the area of the circle. And the area would be radius, so 7 squared times pi. Look how similar these two formulas are. And it's basically the entire exact same thing, except for 7 times 2, we're doing 7 squared. The nice thing about that is we've already reduced this fraction once, so we can just go ahead and we already know it's going to reduce to 5/8. That's awesome. And then 7 squared is going to give me 49 pi. And then we're ready to go ahead and multiply straight across. So on the top, 5 times 49 gives me 245 pi. And on the bottom, 8 times 1 gives me 8. Since those ones are not reducible, I mean, the way you can check to see if they are reducible is think about the numbers that go into 8. 4, 2, and 8. Try dividing 245 by 4, 2, or 8, and none of them give you an even, nice whole number. They're all giving you decimals, so therefore this is not reducible. So my final answer then would be 245 pi over 8, and then our label here, since we found area, would be feet squared. Okay, let's go to the next one. All right, let's start again. We're finding the length of arc XZ, and remember, I know it's not the measure because there's no M out here, so I have to do the full-on formula. The length of arc XZ would be that central angle of 120 divided by 360, there's the fraction, and we're doing length, so we're timesing that by the circumference, or the radius, which is 6 times 2 times pi. So let's go ahead and start by reducing 120 and 360. Both of those numbers are divisible by 120 itself. So 120 divided by 120 is 1, and 360 divided by 120 would be 3. Then I have that times by 12 pi. I can go ahead and multiply straight across, and I get 12 pi on the top over 3. But before I write that as my final answer, I see that both of those numbers are divisible by 3. So I would get 4 pi over 1, or in other words, just 4 pi. So my answer for the length would be 4 pi miles. The next one asks for arc measure. Since it's an M, I know it's just the central angle, which is 120 degrees. And finally, I'm asked for the area of the sector, so I'm going to do central angle divided by 360 times the area of the circle, which would be 6, or the radius, squared times pi. Again, very similar to the first one, but just a tiny bit different. I know that the first one reduced to 1/3, so I'm going to go ahead and reduce this guy to 1/3. And then it's going to be times by 36 pi this time. If I multiply straight across, I have 36 pi divided by 3, but each of those numbers is divisible by 3. So that really gives me 12 pi over 1, or just 12 pi miles squared. All right, next for number 3, we're looking for the arc length from LMN. So our central angle is 210 and our radius is 16. So I'm going to do that central angle of 210 divided by 360 times that radius of 16 times 2 times pi. So I need to reduce these numbers. I see that they're both divisible by 10. But they are also both divisible by 30. The way I'm getting these numbers, guys, is I'm just looking at the front, so I'm kind of ignoring the zeros, and I see 21 and 36. I know that 3 goes into 21, and 3 goes into 36. So then I put that 0 back on. 3 with a 0 at the end would be 30. So both of these numbers are divisible by 30. If I divide both the top and the bottom by 30, it's basically saying 21 divided by 3, that's 7, over 36 divided by 3, that's 12, okay? And then next I have 16 times 2. So that would give me, what, 32? Yep, times by 32 pi over 1. Now we're ready to multiply straight across. 7 times 32 and 12 times 1. Let's see, 7 times 32 gives me 224 pi. And 12 times 1 is just 12. Both of these numbers, 224 and 12, are divisible by 4. So on the top, I get 56 pi. And on the bottom, I get 3. Since 56 is not divisible by 3 and 3 is prime, I know that this is done. 56 pi over 3, and this is in miles. The measure of the angle is just this, or the measure of the arc is just the same as the central angle, so 210 degrees. And then I have the area of the sector, which we're going to do central angle, which is again 210 divided by 360 times now the area, so radius squared times pi. We already know from above that this one reduces to 7/12, and then 16 squared gives me 256. Oops. Pi over 1, and I'm ready to multiply. If I multiply straight across, I have 256 times 7, which will give me, ooh, a big number. Okay, we can do this. 1,792 pi over 12. Okay, let's think about numbers that divide into 12. Well, we'll try 12 itself, and so I will divide this number by 12. Oh, that gives me a decimal. That's not good. The next biggest number that goes into 12 is 6. If we divide that number by 6, still a decimal doesn't work. So next, the next biggest number would be 4, right? 4 goes into 12. So let's try that. Dividing both the top and the bottom by 4 actually gives us a nice answer. The top number, 1,792 divided by 4, gives me 448, and I'll stick a pi with it. And then on the bottom, 12 divided by 4 is 3. Finally, since we have got this prime number, does 3 go into this? No, it doesn't, so that means we're done, and our answer is 448 pi over 3 miles squared, because I just found an area. Last but not least, number 4, let's go after the arc length for FG. So that'd be the central angle over 360 times that radius of 8 times by 2, because I'm doing arc length, times by pi. So 90 over 360, both of those numbers are divisible by 90. 90 goes into 90 one time, 90 goes into 360 4 times, and then 8 times 2 would give me 16 pi. If I multiply straight across, I have 16 pi over 4. But of course, I can divide both of those numbers by 4. And I have 4 pi over 1, or just 4 pi yards in this case. For the measure, remember the measure is the same as the angle, so the measure of the arc is just 90 degrees. And for the area of the sector, we'll do that central angle over 360 times by area, so radius squared times by pi. So we already reduced this up above, and we got 1/4 times by 64 pi over 1. So we can go ahead and multiply straight across, and we get 64 pi over 4. Both of those numbers are divisible by 4, so I can divide both the top and the bottom by 4. 64 divided by 4 gives me 16 pi. 4 divided by 4 is just 1, so my answer is 16 pi yards squared. All right, for the next ones, we're going to be using our angles and circles formulas. These were all talked about in circles lesson 3 PowerPoint. It all depends on where the vertex is on these angles. So let's take a look at this one. I'm finding this angle whose vertex is on the circle, that means the angle equals the arc measure divided by 2. So how could I get that red squiggly line arc measure? Well, I know all the way around the circle is 360, so to find this one, I know it'd be 360 minus the 55 and the 137 that is already there. So that means that that arc has to be 168 degrees, but remember, to go from arc to angle, we have to divide by 2, so that angle measure then must be 84 degrees. Again, the formula we're using for this one is vertex is on the circle. So the measure of the angle equals the arc measure divided by 2. So we found the arc measure to be 168 degrees. We divided it by 2 to get the measure of the angle, which is 84 degrees. For number 6, we are looking for this angle, and it looks like we have a diameter. So that means that from H all the way to F must be 180 degrees. So if this piece is 80, then what's left over must be 100. So that together they make 180. Well, it looks like the angle in question opens up to that 100-degree arc. See the orange or the yellow lines opening up to that red squiggly. So that means my vertex is on. So therefore, my angle equals my arc divided by 2. So my angle must equal my arc of 100 divided by 2. So that means my angle must equal 50 degrees. All right, for number 7, we again have an arc, this guy, that opens up to an angle whose vertex is on the circle. So I'm still using that vertex on the circle idea, where the angle equals the arc measure divided by 2. So I need to either know the angle or the arc measure to solve this problem. It looks like the arc measure is what I'm looking for. Could I somehow figure out this angle? Oh, well, I see I have a triangle. All 3 angles of a triangle must add up to 180 degrees. So angle T there must be 180 degrees minus the 66 and the 76 that were already used. So that angle must be 38 degrees. So this angle is 38 degrees and it equals the arc divided by 2. So if I just times both sides by 2, I'd have that the arc equals 76 degrees. On number 8, we again have a situation where the angle is on the circle. So to get from the angle to the arc that it opens up to, I times by 2. So I have to times this guy by 2. 82 times 2 is 164 degrees. Well, why did I do that? Because I'm really looking for this. Well, it kind of makes a lot of sense to me because I'm looking for this arc measure, this red one. But now I know the other 2, so all the way around the circle has to be 360. So this red one then is just 360 minus the 102 and the 164 that were already provided for us. So that means that red one must be 94 degrees. On the next page, on number 9, it looks like the vertex is inside the circle, but not on the center. So vertex inside, but not on center. The formula is the angle equals the big arc plus the little arc divided by 2. So let's think about this. This arc is involved, that would be the big one. This arc is involved, that would be the little one. And that opens up to this angle. So the angle we'll call question mark equals the big arc, which is the yellow, 190, plus the little arc, which is the red, 56, divided by 2. So I'll just do 190 plus 56. That gets me 246. If I divide that by 2, I've got the question mark or the angle that we're trying to find. So that's 123 degrees. For number 10, my vertex is outside of the circle. To solve for these, I know that the angle equals my big arc minus my little arc divided by 2. So here's the angle. Kind of think of it as like a flashlight beam. See the light? My flashlight is like over here. This is me with my flashlight shining the light. Okay, great. That flashlight beam highlights both this arc and like this one over here. So those two arcs are the ones I'm talking about. I think it's clear to see which one is the big one and which one is the little one. So our angle that we want to find is the big arc, which is 155, minus the little arc, which is 61, and then divide that answer by 2. So 155 minus 61 gets me 94, and then if I divide that by 2, my angle must be 47 degrees. All right, number 11, my vertex is on the circle. So that means that I have to take my angle and times it by 2 to get the arc. So 120 times by 2 gets me 240 degrees. That one was a quick, easy one. Number 12 is very similar to number 10. We are going to use that vertex outside formula, which is the angle equals the big arc minus the little divided by 2. Remember, I've got my flashlight beam, and it's highlighting the little arc, and in this case, we don't know the big arc. That's okay, we can put an X there for it and solve for it. The angle we do know. The angle is 50 degrees. The big arc, we don't know. I'm gonna put X. And the little arc is the red one, that's 55. So see how I just filled in the formula here? Now, I want to solve for x. So the first thing I'm going to try to get rid of is this divide by 2. So the opposite of divide by 2 would be times by 2. So if I times by 2 on both sides, I would then have 100 equals, these 2's cross out on the right. They cancel each other out. So 100 equals x minus 55. So then to finish, I would just add 55 to both sides, and I'd have that x equals 155 degrees. And then you can kind of check to see if that makes sense. If this was 155, then we would do 155 minus 55 divided by 2 to get that. Well, this minus this would give us 100 divided by 2 is in fact 50, so we did do it right. All right. Number 13 is the same kind of idea. Vertex outside the circle. There's a tiny trick to number 13. Let me first write down my formula. I have that the angle equals the big arc minus the little arc divided by 2. I see that I don't know the angle. I have the little arc, but I do not have the big arc. But if you notice, what does the big and the little make? Well, the entire circle. So wouldn't this yellow guy just be 360 minus the 121 that's already there? I think that yellow guy is going to be 239 degrees. That makes sense. Okay, so that means I'm finding my angle, so I'll leave that as x, equals the big guy, which is 239 minus the little 121 over 2. So 239 minus 121 gives me 118 divided by 2. That gives me my angle of 59 degrees. Here I have the angle inside, but not on center. So we have to do the whole angle equals big plus little divided by 2. So here's the angle it's given us, I have this arc and this arc. So let's fill it in. I know the angle is 110. I know the big arc, oh, I don't know the big arc, it's x, but I know the little arc is 50. So I just need to solve this by multiplying by 2 on both sides, and then I get 220 equals x plus 50, because these 2's would cancel. If I subtract 50 from both sides, I have x equals 170 degrees. All right, the next one I have vertex outside. So that means that the angle equals the big arc minus the little arc divided by 2. So I don't know my angle, but I do know the little arc and I know the big arc. So to fill this in, I've got big arc, which is that green 120, minus the little arc, which is 40, divided by 2. So 120 minus 40 is 80 divided by 2. That gives me 40 degrees for my angle. Again, I have the vertex outside. So I'm going to continue with this angle equals big arc minus little divided by 2 formula. In this case, we know the angle, we know the little arc, and we know, oh, we don't know the big arc. So the angle is 60, he's right here, equals the big arc, which we don't know, minus the little arc, which we do know is 63, divided by 2. I need to get rid of that divided by 2, so I'm going to multiply by it on both sides. They'll cancel on the right, but on the left they'll make 120. And then I can add that 63 to both sides to get x by itself is equal to 183 degrees. For number 17, I have the vertex here inside, but not on center. So that means that the angle equals the big plus the little arc divided by 2. So it looks like I have the angle, I don't have the little arc, but I do have the big one. So my angle is 91. The big arc is 130. The little arc I'm going to call x and divide that by 2. Again, multiply both sides by 2 to get rid of that fraction. And it looks like I've got what? 182 equals 130 plus x minus that 130 from both sides, and we have x equals 52 degrees. All right, last one like this, 18. Again, I have vertex inside, but not center. So that means that the angle equals the big arc plus the little arc divided by 2. Here I have the angle, I have the big arc, I don't have the little. So let's go ahead and write this out. The angle is that 130 degree angle inside, right? I have that. I have the big arc, that's 207. I don't have the little arc, so I'll put an X for that. To get rid of this fraction, I'll times both sides by 2, and I will have 207 plus x equals 130 times 2 would be 260. And if I then subtract 207 from both sides, I get x by itself would equal 53 degrees. Oh, very close to the last one. Okay.